Assalamualaikum warahmatullahi wabarakatuh. Good evening. My name is Larasati Nugroho. I'm a student majoring in mechanical engineering from Sampurna University, Jakarta. I am from group 4, and in this video I would like to show you one of the experiments that I have done in this semester. So this video will talk about the experiments about heat transfer and thermodynamic. So this video will be divided into 7 sections: introduction, preparation, assembly, experiment, data and analysis, conclusion, and the last is feedback. Let's start with understanding of our goal in this experiment. So our goal is to calculate the thermal conductivity of some materials they provided, and then we also like to show you how the energy transferred. After we are able to determine the thermal conductivity from the experiment, we would like to compare it with the theoretical one and calculate the percentage error. First, let's understanding about thermal conductivity. Thermal conductivity is a quantity where it utilized to show you how effective a material to transfer a heat. So why it is important? It is important when you would like to design an object that should have certain heat behavior. For example, these electrical wires. You need to make the wires able to transfer heat effectively. So, in this case, copper will be the most suitable material for the electrical wires. And then how we would like to calculate the thermal conductivity. So we assume there is no heat loss due to convection or radiation. Therefore, because of the heat transfer only because conductions, we assume that the heat from a material 1 equals to the heat from material 2. So by this comparison, we are able to determine the thermal conductivity of a material. It is the schematic of our setup. So before the experiments, I did preparations and I divided into 3 steps. The first one, I did research and study. I read some laboratory experiments and watched some videos about the setup. So we able to find the most suitable for us. And then the step 2 is to choose the most affordable and common material plates that exist in our surrounding. And in this experiment, we chose aluminum, iron, and stainless steel. And then after that, we analyze the shipping cost because we are in the group, so we would like to compare the shipping cost from each regions, which is from Yogyakarta and Central Java, and then we purchase the components mostly from the stores that are located in our city. It is some components that we use during this experiment. So we need to have the hot plate, which is used as the source of the heat, and then these plates as the materials, which is aluminum, iron, and stainless steel. And then to have a higher effectivity of conductions, we use thermal paste to combine the to combine the plates to make it stick to each other. And then we need water bag, so the sandwich or the materials that combine it, the plate that combine it, able to reach steady state. And then we use thermocouple that connected to Arduino to calculate the temperature of the plate when it is heated by the hot plate. And then the glove for the safety, because when we would like to remove the iron or stainless steel or aluminum from the hot plate, we need gloves because it will be really hot, so be careful with that. And it is how the setup would be assembly. First, we assemble the electrical components first. So I connect the Arduino with thermocouple. It is the schematic of it, and then I connect it again to the laptop that I use and put some code on there. It is the thermocouple one, it is the Arduino one connected to my laptop. And then the second step is you could just turn on the hot plate. Of course, you should put it on the electricity first, and then you make a sandwich of material. So you choose two plates, two materials, and then stick it to each other using thermal paste. And then you place the sandwich at the top of the hot plate and place the water bucket on top of it. At first, I use the cold water, and then after that you either could use another cold water, but for my case I use only average temperature water, room temperature water. And then after you put it into this sequence, you put the thermocouple between the two material, so you could determine the steady state temperature of these two material until it reaches steady state temperature, which is approximately range from 30 until 50 minutes. You should hold on to it. Be patient, alright? So the experiments that I've done, first I should measure the dimension of each plate. So I measured the width, length, and its thickness using this caliper. And then I done the assembly, and then I hold the thermocouple at the same position. For the first sandwich, I wait for 30 minutes, 50 minutes, and then the next one 50, 50, 55, 45, and then the next one, the last one, it is approximately 30 minutes. And then for each minute that passed, you should record the temperature. I do it for 3 times with 3 different combinations of sandwich. For my case, it is aluminum and stainless steel, aluminum iron, and iron stainless steel. So it is the temperature we assume it as temperature 1, temperature 2, and temperature 3. You should put the thermocouple at the location 2 and wait it until it reaches steady state temperature. So it is the data that I have obtained. It is for the sandwich 1. So aluminum and stainless steel combination. After 50 minutes, I reached the steady state at location 2, which is 185 Celsius. And then I should take a record for the steady state temperature at location 1 and 3 also. If you have extra thermocouple, you could place the thermocouple at location 1 and 3, but for our case, we don't have extra thermocouple. So we just use the temperature at steady state condition. As you can see, the graphic really varies until it reaches 50, 54 and up minutes it reached steady state. And then it is for the second sandwich, which is the combination of aluminum and iron. We received the steady state temperature for the location 2 is 180 Celsius. The graphic not really changed much as the sandwich one, and it reached the steady state temperature at 33 up minutes. It is the last sandwich, which is the combination of stainless steel and iron, and I received that steady state temperature at location 2 is 156 Celsius. The graphics similar to the iron. From this data, we could see that the aluminum and stainless steel really change rapidly in temperature. I could assume that it is because it has the highest thermal conductivity, so it is really easily affected by the changing of temperature. So the graphic really make step change. The change is really big. Different with the last one, stainless steel and iron, the changing not really different too much. So why there is some high temperature and low temperature? So for our case, the hot plate not always on and heating the plate, because after it reached the maximum, it is turned off by itself. So it is one of the factors why the temperature could drop at certain period, and you could see the pattern of it. Same as sandwich 2, it also showed the similar pattern. At certain time, it is dropped because of the hot plate is turned off. I have tried to turn it on when it is turned off by itself, but it didn't affect anything. So it is another information that I received. So it is the dimension of each plate, and after I calculate the thermal conductivity and compare it with the theoretical one, we receive really big percentage error. So only for aluminum it has 95% error, 95% error. Similar as iron, we receive the percentage error 68%. Only stainless steel that has small percentage error. That's because at the beginning of the calculation we use the stainless steel as our reference. So I think that's why it has the lowest percentage error. I got the theoretical temperature from the book of Fundamental of Heat Transfer, where I assume that the material of each plate at uh, at temperature of 30 Kelvin. It is the calculations that I have done using the equation shown on the introductions. In this case, I use theoretical thermoconductivity of stainless steel as K2 because we need the reference to determine the thermoconductivity of aluminum. And as you can see, it is the calculation. Some factors that I've mentioned before that cause the high percentage of error. First, we assume there's no heat loss, which is in the actual experiment, the heat loss due to convection is really high because during 50 minutes the convection occurs and I assume the heat loss due to convection is really high. Also, it is difficult to determine the steady state condition because first there's a problem with the hot plate. So the hot plate not always turn on, but sometimes it turn off by itself. And as I mentioned before, it is turned off at certain period of time. And then the error might also come from the thermocouple. So the thermocouple should able to remain constant, but because there's a human error for myself not able to maintain it at constant positions, so it is really difficult to exactly measure the temperature. And then for the previous one is for the heat transfer analysis, it is the thermodynamic analysis. So we realize that there's a change of temperature for the water. For the first case with sandwich one, the difference of temperature really high. It is has a correlation with the high thermal conductivity of aluminum and stainless steel. It is proven that the height difference of temperature also showed that this combination has the highest thermal conductivity, the total of thermal conductivity compared to each other. And then the thermodynamic aspect of it, we're able to see that there is a heat transferred from the hot plate through the materials and until it reached the water bucket and boil the water. So for the conclusions, I've learned that the thermal conductivity affects the heat transfer rate significantly. So the higher the thermal conductivity, the better it is to transfer the heat. And then there are many uncontrolled factors that it is still difficult to model in these experiments. For example, the convections, the radiation might be occurs, and there might be the theoretical theoretical thermoconductivity the not the same as the material that we use, and then the problem with the hot plate that not always turn on. The feedback of this presentation or this experiment, it is, I think, because there's a high heat loss come from the convection, it is better to find a way to at least decrease, or if could, really terminate it. And then it is better to record the temperature change at 3 different locations, because we know the steady state at 3 different locations, not at instant time, but it is needed to have extra thermocouple. And also I wish I had a better camera to see better quality videos, so the people could see my experiment with uh, with better understanding. I think that's all from my videos today. Thank you very much for watching it. Have a nice day. Thank you.